Hello everyone, in this video we'll see about the Cuk converter. In the previous video we saw about buck converter, boost converter and buck boost converter. Now there are some advantages of buck converter and demerits or disadvantages of buck converter. Similarly, in case of the boost converter there are also same advantages and disadvantages. In case of buck converter, what happens? In case of buck converter, we have seen that for the circuit diagram during fault conditions, the load in DIDT, that means inductor was connected, so DIDT is limited by the inductor, and high voltage rating of switch is required. Here high voltage rating of switch required, because as per the circuit diagram of buck converter that I have uploaded in the previous videos, that switch across the voltage across the switch, that is becoming very high in case of the buck converter. So high voltage rating of the switch is required, and input current that was discontinuous in nature. Input current was discontinuous. Why input current was discontinuous? But because the circuit diagram was like this, there was voltage source like VDC or VS, whatever you can see. Here inductor was connected, so whenever the switch is on, then current flows or source current flows. Whenever the switch is off, then it becomes the open circuited, then current does not flow during the off condition, or 1 minus d into t, where d is the duty cycle, t is the time period. So input current is discontinuous, it is not continuous throughout on and off time, so it is one of the disadvantages of the buck converter. And smoothing filter is normally required to provide single polarity output voltage and unidirectional current. Okay, and in case of the boost converter, whatever we can see, that inductor was connected like this. In case of boost converter, inductor was connected like this, so supply voltage was there, then switch, then following the direction whatever was, so limited by the inductor, that is the DIDT. DIDT changes current, inductor does not allow the sudden change of the current, so that is why it limits high amount of current through the source or the source current. Okay, now input current is continuous. In this case, input current, that is the IS or source current, that is becoming continuous here. Why input current is continuous? Because whenever the switch is on or off, the current always flows through the inductor. Maybe whenever switch is on, then current flows here and bifurcated from there as per the KCL or Kirchhoff's current law. Whenever the switch is off, then also current flows like that. So there is no time when the current is becoming off or zero, like discontinuous mode of conduction is not there. So input current is always continuous, and larger filter capacitor is required. Now we will use the input of boost converter. We will use the input of the boost converter because that is the merit of this boost converter, and output of buck converter because that was the merit of buck converter, the output of the buck converter. So if we combine the input of the boost converter and output of the buck converter, and we join them in the cascade fashion by energy transfer capacitor by 1 energy transfer capacitor, then the converter that we will get is Cuk converter or Cuk converter. So Cuk converter or Cuk converter, then we will get. So what is the circuit diagram of the Cuk converter? That is like this. The input should be as per the boost converter. There is switch, let's say IGBT or MOS that is connected, you can use. So plus minus, that is the supply voltage. Okay, and L1 is connected over here. This is switch S or T. T means transistor. So one energy transfer capacitor will be connected, and diode will be connected. This is the freewheeling diode, and inductor was connected over here. Capacitor is connected like this, and resistance is connected like this. So it is L1, it is L2, it is C1, it is C2, and it is diode D. So it is the circuit diagram. It is the circuit diagram of Cuk converter or Cuk converter. Okay, now what happens whenever the switch is on? Let's say AC is on. AC is in the on condition. then it becomes shorted. So whenever the AC is becoming in the on condition, So circuit diagram is going to be like this, and diode is becoming the reverse biased condition. So because this anode terminal is connected to the negative polarity of the battery supply voltage, okay, so this diode is reverse biased. Reverse biased means it is acting as open circuit, and capacitor is connected like that, this one direction, and inductor is connected like this, capacitor is connected like this, C1, L2, this is C2, and this is R. Okay, now you see that this supply voltage current starts flowing, so inductor will be charging like this, plus minus polarity, and this capacitor was initially charged like this, plus and minus VC1. So this will start to flow, current will start to flow from this voltage, as it was storing VC1 voltage across the capacitor initially. So total current will be flowing like this, the supply current will be going back, and as per the KCL the current will be flowing like this, and this will be the direction of the current. Now you see the output direction of the voltage is like reversed. Upper one should be positive, lower one negative. This is the convention, but here we are getting upper one negative, lower one positive. So output is getting inverted. Output voltage polarity is getting inverted on negative. That's what the conventional direction. If we take the voltage across this and this, then it will be negative, or this and this, then it will be positive. So this is the speciality of the Cuk converter. In the Cuk converter, this type of arrangement happens. So we will see now the waveform regarding the Cuk converter. Okay. So the waveform regarding the Cuk converter. Let us write the heading waveform. Now we will see about the gate pulse. Gate pulse means the when the switch was on and switch was off, because the switch that we are using, that was IGBT, insulated gate bipolar transistor. Okay, so let's say duty cycle BD. So that time the switch was on, and 1 minus D into T, that time switch was off, and this was the pattern of the on and off. So this is the shaded region, it is the on, that means in this case the gate pulse was applied, in this case the gate pulse applied was 0, so it is in the off condition. Then also it is on condition, it is in the off condition, then it is in the on condition, then off condition. Okay, it is the time T. Okay, so voltage across the thyristor. So voltage across the thyristor or transistor, whatever is, so that will be like, follow the diagram. So you see voltage across the switch or IGBT or transistor, whatever you say, whenever the switch is on, then it is short circuited. So voltage across the switch is becoming 0. Whenever this is off, then supply voltage, that is the let's say Vs minus V of this L1, that is becoming the voltage across this, as we apply the KVL. So whenever the switch is off, then we will get the voltage across the thyristor or voltage across the transistor, let's say IGBT. So whenever the switch is off condition, then only we will get. This is the waveform. Okay, I hope this makes sense. Then we will get the waveform of IL1, that is inductor charging current. So IL1, whenever the IL1, you see, whenever the switch was like on condition, then it was getting charged like this. Whenever switch will be off, then what will happen? Whenever switch will be off, then inductor was becoming like this, plus minus, then switch is off, that means it is in the open circuit condition. Then capacitor will be like this, diode will be now this will be now changing its polarity, because inductor, whenever it is fully charged, now it is time to inductor for discharge, so it reverses its polarity as per the Laplace transform that we are getting. Proof also is given in the previous videos. So negative, it will be positive. Now this is positive, this is negative, because inductor does not allow sudden change of current. So current will be flowing like this. So current will be flowing like this, and this inductor will be like this. So this inductor will be charging to polarity as per plus minus, and this will reverse its polarity minus plus. Now the cathode of the diode is connected to the negative polarity, so it will be now in forward biased condition. Now as it is forward biased condition, now we can replace it as short circuit condition. Okay, now it will be in the short circuit condition like this, whenever the switch like L2 was connected like that. Okay, fashion. Then capacitor is connected, then the resistor is connected R. So meanwhile we are getting that whenever the switch is on, diode is getting charged, so this charging phenomena will happen. and whenever that is off, so discharging of the diode will happen. Then again charging and discharging phenomena will happen, so we will get the waveform like this. So this is IL1 minimum and this was IL1 maximum. Then we will see as per the waveform of the IL2. Now IL2, applying KCL, we get that IC2, IL2 also charging and discharging, same kind of phenomena will happen. Charging and discharging whenever on, then charging whenever off, then discharging. Then we'll see about the waveform of IC2, that is capacitor current C2. So IC2, if we apply the KCL here, so IC2, that is the capacitor current flowing through this. So IC2 is nothing but IL2 minus I0, because it is the continuous current I0 that is taken as per this direction I0, and IL2, let's say this current IL2, so this is the IC2 current. So IC2 is IL2 minus IL0 as per the conventional direction. So I0 is constant, continuous and ripple free. So I0, that is the output current, that is continuous and ripple free. That means the constant current, continuous and ripple free. So continuous current is there like straight line. So whenever we will subtract this IL2 minus IL0, so it will shift its direction, constant direction. So graph will be shifting like this. So this will be the waveform of IC2. Now the last waveform that we will get the IC1, that is the capacitor current 1. So capacitor current 1 is nothing but IL2 current. You see, whenever the switch was in the on condition, the IL2 current, this current, the flowing this current IL2, series combinations of same current will be flowing like this, capacitor and inductor, but the direction of the IL2 is taken like this, as per this direction. But actual IC1 current, so IC2, that current direction also taken like this, so conventional direction. So IL2 is flowing like this, but actually IL2 flowing like in the opposite direction. So IL2 is nothing but IC1 nothing but IL2 whenever the switch is on condition. So IC1 nothing but IL2 whenever the switch was in the on condition. So this is the in the on condition, and whenever the switch was in the off condition, then what will happen? Whenever the switch is in the off condition, then this switch becoming the open circuited, then you see this is capacitor, then inductor, then diode is connected, in between the diode is connected. So IC1 now becoming minus IL1. So IC1, whatever current is flowing through the inductor, that is becoming the negative of IL1, this one. Okay, so because this is the negative of IL1, so we'll get the IL1 waveform but in the negative direction. So we'll get like this. Okay, so this is the waveform regarding that. About the Cuk converter. So Cuk converter comprises of both advantages of buck converter and the boost converter, but it is not the buck boost converter, because buck boost converter will not get this type of waveform, or in the buck boost converter will not be getting the merits combined way of buck converter and boost converter. There we will see that this converter can be used as buck converter or boost converter by changing the duty ratio that I have seen in the previous video. Okay, so I hope you got this video clear and this makes sense to you.